It's given that f of z is this cubic, and the points representing the three roots, f of z equals 0 plotted on an argand diagram, show that they lie on a circle modulus of z equals k, where k needs to be determined. Okay, let's find the roots to this. So our process is going to be to try and use the factor theorem. Put in some values until we get 0. Now f of 1, there's no way that's going to be 0, so I'm going to skip it. The next one that kind of makes sense to try is f of 5. And then we'd get, and I would show my working for this, but you can use your calculator to help as well. So 5 cubed and then minus 13 times 5 squared, or 25, that's 325, plus 325, 65 times 5, minus 125, and we can see really quickly it's going to be 0. Therefore, z minus 5 is a factor. And we can guarantee the other two factors are going to be complex numbers because it's talking about them lying on a circle. I used polynomial division to get the rest. Up to you. But it's a solid method. Okay, so z into z cubed, z squared, multiplied back through. So I'm doing different. I normally do it in a different color. Z cubed minus 5z squared. Subtract. Bring this one down. Repeat. Minus 8z. 25z minus 125 gives us plus 25. Okay, and it checks out. So either z minus 5 is 0, or xz squared minus 8z plus 25 is 0. So I'll write that down. So z equals 5, or okay, we have to show detailed reasoning. You could use the quadratic formula, but actually when I did it, I thought I'd just complete the square. Z minus 4 squared minus 16 plus 25 is going to give me plus 9 equals 0, so this will actually equal minus 9. That means z minus 4 will be the square root of minus 9, plus or minus the square root of minus 9, which will be plus or minus 3i. And there we go. Z is going to equal 4 plus 3i, or 4 minus 3i. When I did this question, I thought, I'm going to sketch this out roughly. Okay, although this isn't actually going to help. So we've got 5 here, and 4 plus 3i is maybe here, and 4 minus 3i down here. So you can kind of see it's going to be a circle, but that is definitely not, evidence enough. What we have to do is find out the modulus of z in each case. So the modulus of 5 is just going to be 5. The modulus of 4 plus 3i, well, that's this point here. We use Pythagoras' theorem. We're going along 4 and up 3. So 4 squared plus 3 squared square rooted, which is root 25, which is 5. And the same, because it says we have to show they all lie on this circle, so 4 minus 3i is going to be exactly the same. 4 squared plus, well, you can do minus 3 squared if you want, but it's the same thing. So therefore, modulus of z equals 5 for all roots.